This is the second part of a workflow that uses a delta function to scale the isotropic velocity model to a vertical velocity, in this case derived from well checkshots or VSPs. If you have not seen part 1, look for it in the Dug Learning section of the online help first. After using synthetics to create delta curves for each well in the session, the data is now ready for input to the 3D delta model and velocity correction. The correlation view is highlighting differences in blue and red between the checkshot velocity and the velocity extracted from the interval velocity volume. The arbitrary line is showing the delta curve computed in the synthetics module overlain on the interval velocity volume. The delta curve is calculated from differences between the velocity and the checkshot curves using Svansky's formula linking the ratio of V0 and VNMO to delta using the equation seen here. The arb line through the 3D survey shows 4 interpreted boundary horizons that can be used to constrain our calculations. To use the horizons in a process, I must first include them in a model. Select the Model tab and click on the blue cross to create a new model and give it a name. Select the correct domain of the model and add 4 interfaces, one for each horizon. Assign the correct horizons to each interface. Now all the inputs are in place, I click on the Process tab and create a new delta model process. The process can be renamed if required. Select the windowed model just created and adjust the output extent to match my velocity volume. Add all 5 wells and select the delta curve generated in the synthetics module in part 1 of this workflow. Using the structure defined in the windowed model, the delta curves are interpolated to a delta volume by the delta model process. The volume can be selected in the section view to check against the input delta well logs and to check the interpolation between wells. Then create a new process to apply the delta model. The process is called V0 from delta and isotropic depth migration velocities and can be renamed if required. The V0 model is calculated using Svansky's formula linking the ratio of V0 and VNMO to delta using the equation seen here. The process uses 2 inputs, the VNMO, which is the isotropic seismic interval velocity in 2A time, and delta, which is the delta model just created. The result is a corrected velocity volume that ties the velocity at the well locations. The corrected velocity can be seen in the section view, and the log curves can be changed to interval velocity checkshots to review the quality of the tie. If the process has worked, the logs will blend almost invisibly into the background velocity, as can be seen here. The final velocity can be compared with the original velocity using the mouse wheel flip between the 2 volumes to see how much change has been applied. This looks great! The velocity ties the wells with minimal changes to the original. If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight!